you what I did last night. That's less salacious than it sounds. Okay, so we were writing code yesterday. That was, what is that? That's garbage. Oh, that's not. All of this is broken. Okay, so we were writing this lazy literature type of program the other day, and were you the class that was enthused about Lord of the Rings? Okay, so I fixed the Lord of the Rings files so that we can actually generate stuff. Okay. Today I want to start doing something which is going to save me a lot of time. Surely you've seen this in programs. Right? This thing right here. What this means, basically, it says if this file is called by Python from the terminal, all the stuff in this if statement should run. So I'm going to just put that back for a second. Whoops, what did I do? Go away and go away. I'm just going to grab this. I'm just going to start a new wrap. You all need to see all my personal files. Touch. What day is it? Wednesday? Hump. Code hump. Okay, so I'm going to just define an arbitrary foo function. Suppose it takes x and just returns x. Now I'm going to dump in this, and I can say print hello world, and then print maybe foo at 7. And then if I go out to here and I type Python hump, it's going to read in the whole file and then execute everything that's in that if statement. Right? So this is just going to prevent me from having to type in a whole set of statements every time that I want to test the code, because that was a big time sink. So what I'm going to do today is just write everything in here rather than using the interpreted language. Okay, so what have I done? What have I done? First of all, this should be out. Okay, so I modified our code a tad. So just let me read it in. Now that I've said, let's get rid of this. So just let me read this in. Okay, so the first thing I changed was this. Remember how we're building this context dictionary? This is a dictionary that was going to tell us what words come after words in the book. So the way that we wrote it formally was we would give it a book and it would return a dictionary. Now, Lord of the Rings has 3 books, right? So I had to change this function a bit, right? Because I want to update the dictionary with new information. So that's why I added dictionary here as a input. So I'm telling to the user, I'm saying, user, you have to hand me a dictionary, and I'm going to update that dictionary. But you're the ones who have to create it. So the way that this works now is I can say something like this. Open, and I think I changed it to Tolkien. Oh, that doesn't work there. Tolk1. So I can create a book. Open Tolk1.text for reading. I'm going to make a dictionary, which is going to be my context dictionary. And now I can just say, update my context dictionary with this book. And we'll see now that H has stuff in it. Right? So the benefit of this now is I can read in now a new book. I better close the other one. How do I close a file? Is it like this? Book.close. Great. New book is open, maybe Tolk2.text. I'll read that. I still have my dictionary with stuff in it. But I'm going to now say context dictionary Here's the next book. Here's my dictionary. Yeah. Yeah, that's not a bad idea. That's the length of the dictionary. Now I'm going to update the dictionary. Whoops. Context, dictionary. Going to give it the next book. Going to give it this H. Processes, what's the length of H now? Great, more. All right, let's close the book. Let's get the next one. Tolk 3. And now I'm going to add those contexts to the dictionary. And it's gone up a bit, right? So you guys are a little bit confused with this in the assignment, right? When we gave you this rotate map function, right? Because it was happening in place, right? So there are two ways to pass things to functions. Like we never said it really by name, but there's pass by reference and pass by value. So you guys are used to this pass by value. I give a function x, but it's just like seeing x's too. A pass by reference is what would happen if we pass a list or something, or a dictionary. We're not passing values of the list or the values of the dictionary. We're passing the pointer to the dictionary, right? So this is one way where you can have a single dictionary which you can update, which you can hand to a bunch of different functions to have the functions do different things on, but it's always the same dictionary. Passing by value here would be a disaster because we'd have to duplicate the dictionary, which already has 16,000 keys in it. Okay, so that was the first thing I updated, was I wrote this function to be able to update a dictionary. The next thing I did is I also wrote this clean definition. So when I put a word into my dictionary, I'm going to clean it a bit. I'm going to delete, well, can anyone tell me what this is going to do? Let me just get rid of this. So like, these are good questions to give in an exam. Like, here's a piece of code. Tell me what it does. Stretching or answering? Answering. Go crazy here. Okay, could you convert the algorithm I wrote to English somehow?
Yeah, so you start with the word, the dictionary, and pick out a different function, and you set up an answer to its concern. And then you look at every character inside this.
Well, I'm more trying to get you to read out what this does.
Yeah, for every character in the word.
Well, this.
Except for the empty spaces, you do the empty spaces.
Great. Okay, so I take a word and I strip all of the left padding of like spaces, and I strip all of the right padding.
So you strip the overall.
Yeah, oh, is there a strip? Oh, okay. So I'll just do this. Yeah, word.strip. Okay. Yeah, so what I've done is I just pulled out all the apostrophes, including the periods and stuff like that. I no longer care that a word is like a period word. It's like I've sort of actually reduced the functionality a bit here, but this word cleaner helps quite a bit because the files were fairly messy. Okay, so then the other thing that we did is then I sort of said we could like maybe pick a start word like the, and then we could generate the next word like this somehow. Whoa, that was wrong. Oh, I have to randomly select. Yeah. So I also have this. We wrote this other thing too. What? How am I randomly? Oh, random choice. Okay. Okay, so we have the. So remember, these are all the things following that word. It's way too long to print, I think. Yeah, Jesus. So another thing that I realized that we didn't do. I'm sure. Okay, so let's look at the. Oops. Whoops. Wow. Cooperate. Okay, I'll just say it out loud. I didn't bother to check if a value was in the dictionary for a certain key. So when I say h of word, this isn't giving me a list of unique words back. It's giving me a list of all the words that follow to. So we have the, and we look through Tolkien's book and look for every word that follows the. But if I find the phrase the king 50 times, king is going to be in the dictionary 50 times. Now, is this a bad thing or a good thing?
It's a good thing because you use the words that are most often used next to the more often.
Now play devil's advocate and tell me why it's a bad thing.
You're discriminating against the use of other words, so the gibberish isn't going to be gibberish.
We can't discriminate. This is Canada. Another way to be that this is bad is that it's like we're using way too much memory. Even if we did want to keep the word frequency, we should do it as word frequency pairs. Like instead of storing king 50 times, we should store like a tuple of king 50. But we'll leave it like this because I like the fact that our mistake meant that our random selections are actually doing something smart. Right? It's using something called the prior. It's going to choose words, like if king comes after the a lot, we're going to bias towards that. But this is a good bias, right? Because we're trying to generate gibberish text. Okay, so what we have h of the. So I wanted to say our first word, like I built some type of routine where I said the word is the, and then the next word is a random choice from here. Random choice. Like this. The eyes. Whoops. The defense in the man. We'll leave it at that. Okay? So there is this process that like we could use to generate gibberish sentences, and I just wrote that process into a line here. Right? Gibber line. So a gibber line is going to generate one line of gibberish, and I'm going to give it the maximum number of words to generate. Because I now that I don't have stop words, like words with periods after them, like I'm going to have to say how long the gibberish line should be. So what this gibberish line does is it takes the context dictionary and the max number of words, and it just accumulates into this answer variable a sentence by just. Now, how did I choose the first word? So yeah, the one thing I did keep is that these are all the words that begin sentences. Right? So I'm going to choose my first word from the collection of all words that start any sentences in any of the three books. Yep.
What are there elements in that list where it's only an empty string?
The keys or the values?
Check the dictionary for
This?
Yeah, there's some values that are empty strings.
Yeah, so there might be bugs in my code. For example, I may be cleaning words away entirely, right? Like if it detected a word was like a punctuation, right?
Well, maybe those are the new ones.
Well, stuff in like that shouldn't be there. Anyways, what did you have up there?
By removing periods and optimize the gibberish line function the way it is now, it's going to return the exact same length sentence every time you run it. Right? Before it was stopped when it hit a period, which was randomly chosen. So
Well, now I'm just going to stop at like a randomly chosen number of words. I agree with you that I've somehow removed some of the functionality by like removing those period words. Like we could put it back. I'm just trying to like we don't like our goal here is just really well, the thing I found then only stopping at period words was that I was generating sentences that were like hugely long. Right? Like I was generating sentences of like 80 words, right? Because it was just going until it like randomly hit an end of a sentence. So like it turns out that there's no reason we should expect a process that has to end at one of those terminal words to be an appropriate average length. You know what I'm saying?
instead, you just have a random selection going a reasonable range of word lengths.
Well, yeah, I'm going to have to truncate it somehow, right? So,
Like 5 to 25 or so.
like, we can think about how to improve that. Like, keep that in mind. So for version 2.0, let's see if we can bring that functionality back somehow without generating huge sentences. Yeah.
Maybe the way to do that would be referencing the previous, like starting at the last word.
Yeah, that's exactly what we're going to do today. Build longer contexts. So let's just finish what I was doing here.
It's like we're starting at the beginning of the sentence, right?
We're going to start at the beginning, yeah.
Right, maybe starting at the end.
You want? Well, how would that work backwards?
Yeah.
That's the same problem.
An arbitrary sentence.
Okay, that may work too. But anyways, let me just show you how this gibberish line works, right? So I have this gibberish line. I have to give it my context dictionary and then like a set of words. Okay, so here's a gibberish line from Lord of the Rings, right? Where many men away towards. It does kind of sound Tolkienese in a way. Random.randint. Maybe I want to generate sentences that are a minimum 5 words long, but at maximum 10. The hoofs behind the gaffer, though worm, which will indeed there a purpose. Then coming up to drink to do. Anyway, so we can generate pretty okay gibberish sentences. And if we wanted, we could probably... Did we generate anything funny? Okay, so the next thing I want to do... So I'm gonna leave this now. And I'm going to undo this. And what I have done here... I collected all the Dr. Seuss... Well, I collected a bunch of Dr. Seuss literature. And I have 1, 2, 3, 4, 5, 6 files. So what this is going to do is just read in those 5 files, right? So in a loop, right? I'm going to say 4K in 1 through 5. Oh, that dictionary should be outside. 4K through 1 through 5. Open Seuss K for reading as book. And then load my context dictionary with that book. And then let's just generate some gibberish sentences. How many should we generate? I don't know, 10? And let's say gibber line with this context dictionary, random, randint. So these are Seuss sentences, right? So we want stuff that are like short. So maybe 3 to 8. Let's see what kind of gibberish sentences we get. We don't need gibberish sentences. I'm writing gibberish Python. What? Oh, I have to print. Now wait, A. This is not. Would you some are red wood, and Sally and my little, my name is good. They are tame, and I do not. Have you would not like to, and our mother will not be something. Have no fear, little toy. Killed it. May not be Dr. Seuss, but maybe like Dentist Seuss or something. Master Seuss. We could try it again. So I was debugging this last night, right? And what do you think I needed to do when debugging that you guys hated? This is a random process that I'm trying to debug, right? So to throw the error that I wanted to throw, I had to use a what? Yeah, if I turn this on, same random output, right? So I wish you guys, well, not really. I was going to say I wish you guys were looking over my shoulder. I'm like, that's in my house. That would have been creepy. But I wish in this setting, you could have seen that using a seed like saved our ass in terms of debugging. But in any case, Luke Luck licks in. You like them with a tip. Oh, God. But I do not like them. I have one little bit. Why do was, would you sir choose to brush? These yellow pets are. I have to open many. Bim and thing two and thing. But he likes to brush and the things. Anyways. Okay, so that's our gibberish generation. How much time do we have? Now, that was version 1. I am now going to just duplicate this. Let's do version 2. Let's improve it. Any ideas? How we can improve it? Like, how is our gibberish sort of bad? Let's go back to the Tolk one. Whoops. Tolk one. 1 through 3. They rested for a soft as, then coming of the nearest equivalent that startled. Better not give up. Give us up came Gimli. Then there was liable to. However, it what? Okay, so how can this be improved? This is clearly gibberish. Let's think more about our broader goal of like generating a gibberish book. So like depending what you guys want to do today, I don't think it would be too bad of an idea to try to get as much like statistical information from the book as possible. Like what is the average sentence length? Like what is the variance of the length of the sentences? Like what is that for paragraphs or stuff like that? But otherwise, but that's not really going to improve like how our gibberish sounds. It's just going to make our gibberish look more like a book. Yes.
Maybe when we're generating, like we can be aware that we're generating a paragraph and count how many times a capitalized word shows up, because that's usually the name of the place or the name of the
Oh, I stripped all the capitals.
Oh.
Yeah.
But how come they're like printing Gimli with capitals instead of that with capitals?
Oh, then maybe I didn't change.
So like,
Oh no, up is not capitalized either. Oh, up is capitalized.
maybe like update of values, like how often that word shows up. So like you prefer to use that word, so the character shows up many times in one paragraph.
Okay. Any other ideas? Like I need to be able to do this in like 20 minutes. Any other ideas? I thought you guys were up all night struggling and with this problem. Yeah.
I think that we can make a list of just really common prepositions, as, or, and, but, not, for instance, and just check at the end of every sentence generated if it ends with that word, and just clip that one off. Because most
Okay, so you're saying that that's not a bad idea, actually. Okay, so what would make our sentences sound better is if they didn't end with words that required other words to come after them, right? Like, yeah, and that shouldn't be there.
and you find another preposition after the one you keep removing it so it gets something that's not like those prepositions.
Yeah, that's too far, I think. I don't think we're going to be able to classify our words into like prepositions, nouns. But what we can do, like let's look at the word frequency. And maybe we should just say, look, if a word is very frequent, it should never end a sentence. Like maybe we can figure something out like that. Like maybe the most frequent words are like these, are just like the simplest ones. I don't know. Let's look. Let's try some, let's see what we can do. So this is just going to read in the dictionary for, do you want to stick with Tolkien or do you want to switch to something else? Tolkien, geez, big surprise. Okay, so I should have my dictionary. What? That seems small. Didn't we have something much bigger than this? Oh, right. I missed the book. Thank you. That's better. Okay. So, how do I get... I now need a unique word list of everything in my dictionary. How can I get that?
For loop through every entry in the dictionary, and then another for loop inside that for like every item in that list, add it to a list which would represent the unique words. If it's
Yeah, I get where you're going, but that only puts values into the dictionaries. What about the keys? You've only put all the words that follow words into the dictionary. What about all the words that don't follow anything?
then put that same
Yeah, we're also have to go to put the keys in. Okay, so maybe I'll just do it in here. Definition word list, right? Or maybe we'll just do word frequency. Word frequency. I want to be given this context dictionary. Where did it go? And I don't really know what we're going to return. I think we're probably going to return a dictionary, right? And the dictionary should key string keys to integer counts. Okay. So that, you know, returns word frequency of the context dictionary. Okay, so we have 4 key in H. We can look at H of key, and that should be a list of strings. Okay, so I have this. Okay, so 4 word in H of key. Okay, so I need a frequency dictionary. So it's going to be my frequency dictionary. So if word is in F already, then F of word gets incremented. Else, F of word gets set to what value? 1. Yeah, not 0 this time because I have found it. Yeah.
Can we also do that outside because we're also wanting to include the keys?
Yeah, I'm going to have to put the key in now as well. But I could also do something like this. Just throw it in to the processing. Right? It's a little bit of a hack, but it's an okay one. I think that should work. Okay, so uniqueness should be handled by the fact that I'm keying into a dictionary. So let's see what this returns. Just read everything else. So here's my frequency. Let's do a word frequency on our context dictionary. So what? Okay. What do we got here? What's the length of F? Wait, that can't be right. Oh no, that can be right. No, yeah. Sorry, this is correct. There has to be. So each key in the context dictionary is unique, right? So there's going to be at least as many things in the frequency list as there are in the number of keys in the context dictionary. But there are also words in the context dictionary that aren't keys, right? So that's why we have more stuff, right? Because there's maybe a couple hundred words that maybe just only end sentences or never get to be keys. Okay, so now I want to look at I want to find the most frequently used words. So how can I do that? So here are the items, or maybe let's look at the keys. Those are the keys. We can look at the items. Wait, those aren't numbers. Oh, yeah, sorry, F. A lot of 2s. Okay, so how about we reverse this now? So I can say, what are all the words of length 2 that are in here? What are all the words of length 3? Oh, no. These aren't lengths. These are frequencies. All right, so let's write another one. Most frequent words. So I'm going to give it now the frequency dictionary. And I want to, maybe we're going to ask for the n most frequent words. And we're going to return a list of strings. Okay, so I'm going to give this function our word frequency list. Let's try and determine what the n most frequent terms are. I don't think I'm going to be able to avoid doing a sort here. Any ideas? Yeah. Yeah, that's my other idea. We can just sort of reverse the dictionary. So 2 will give us all the things. Yeah, let's just do that. So let's invert this dictionary now. But remember, when we invert, we have to, the thing that we're inverting has to go to a list, right? Due to the fact that this isn't one-to-one anymore. Or maybe why don't we just fix this then? So instead of keying the, oh, no. We need the word frequency list before I can reverse it. Okay, so that's not going to do much. Word frequency, and then we'll just say this is frequency word. So this is just going to invert the dictionary. Just inverts F. So I'm just going to call this H. It's going to be a dictionary. For key in F, what do I want to do? How do I invert this dictionary? Yeah.
We first add all the like every unique value to the dictionary as
So for key in F, so F of key is going to be what? A number. It's going to be a word number pairing. So this is word frequency. Does that work? Can I say that?
we only store things in the frequency dictionary for every key. Like F at key should be in it.
Yeah, F at twang should be an int. Yeah. So F is the keys here are going to be words, right? And then F of key is going to be an int, so that's correct. So why did I put this here? This is going to be a word in F. Frequency is this. So this means H at frequency. Okay, so now I need to do this. If the frequency is already in H, then H at frequency, you append this word, right? Else, H at word has to get instantiated to this. And then return H. Yeah?
First of all, your F is set as a key, like frequency equals F of key, but you change that to word.
That is correct. And this should be a word. No, that should be frequency. Wait, what am I doing? Frequency, yeah, H. Yeah, different dictionaries here, so return H. But we're not actually trying to return H. I want to return, okay, let's just return H for the time being and see what happens.
H at frequency.
H at frequency.
H, like in the else statement, should be H at frequency equals word.
You're correct, yeah. Okay, so what do I want to do? I want to, get my word frequency. So F is word frequency of H. So let's just see, yeah, that's fine. And then I want to get G, H, F. Did I have used G? I'll use G. Frequency of words, I'm going to give it our frequency list, and I'm going to have to give it a number, even though it's not going to do anything with it. And then what should G look like? Okay. G dot keys. Should just be numbers. Great. Okay, so now we're in, so we can sort these keys, I think. No? This is a, what is this? Oh, right. It's an iterator. Whoops. Huh? Oh, you guys are getting so smart. Yeah, I think this should, Jesus, Murphy. X is this list? Yes. Okay, so X dot sort. Great. So there's a words that have appeared 26,676 times. So what do you reckon those are, right? The. Okay, right? So we should never end a sentence with the, right? That's probably like something that we can figure out. What about this one? What do you think the second most common word is? And. What about the third most common word? Now you got BA. Okay, so let's go back to our word frequency list so it actually returns now like the n most frequent word. So how did we... Okay, so we need to sort the... Okay, so the frequencies are what? The frequencies are going to be a list of the h dot keys, right? The keys here are the frequencies. And then I'm going to sort this.
If you assign that sort of right, it's going to be
Wait, this is not going to work?
none. It's going to be none.
So then I can do this. Okay, so this is going to, I think, I'm just going to say reverse equals true. Okay, so maybe I'm not going to return the 10 most common words, but I'm going to return the 10 most common frequency groups, right? So like there's like the is the most common. Well, I don't actually think we hit anything with multiple stuff in it, did we? Well, it's certainly going to be the case that some of these smaller... Geez, we have to go really way up the ladder here. Okay, so like G at like these words appear 78 times. Yeah. What word only has a frequency of 1? If any of you guessed this, A+ in the course. What word appears exactly once in the Tolkien trilogy Lord of the Rings? Any guesses? Monkey. Okay, we have monkey. Forbearing. Yeah, yeah, you screwed me up. There's a bunch of words that should only appear once, right? So these are all the words. So did anyone get, is there monkey in here? No, is there forbearing? Brisk. Brisk appears exactly once in the Lord of the Rings book. There you go. So this is good for your pub trivia, guys, right? The beak-like appears exactly once in the Lord of the Rings trilogy. Untasted. Maybe they didn't taste the thing that was beak-like. Okay, anyways, we're getting sidetracked. Okay, so now I want to return a list of the most frequent things. So, okay, I need to return... Oh, you guys are going to get mad at me for doing this, but we'll see. Okay, maybe I should accumulate. I should just make this easy. So now, here's our answer. We have to accumulate a list. And then we're going to return that answer. So the n most frequent words. So for k in range n, what do I want to do? I want to walk the back of the list. So here are my frequencies. Yeah, I reversed the list. So the thing at 0 should be the most frequent thing. Yeah. So this is going to be the most frequent thing. And I want to extend the answer by that, right? Because these should be lists. And then return that. So let's get out of here. Let's go into here. So I have an H. I want F to be my frequency words for H. What? How many? What? Oh, no, word frequency. Jeez. Mondays, am I right? Okay, G is going to be our... Oh, no, but that's no longer a dictionary. So this is just going to return something. Frequency word. For F, I want the 10 most frequently used words. Int object is not iterable.
Range.
What's the error? 76. Answer dot extend. No, but what's that frequency at k should be a list. Okay, I'm just going to add some stuff down to our... Hey, where did my header go? Oh, here.
Frequencies. Yeah, frequencies is numbers. The items in frequencies is incorrect as numbers. It's the keys. It's just the keys of the dictionary.
So this is just a number?
Yeah.
Oh, right. Sorry, I'm keying into the wrong dictionary. This should be F at frequencies of... Yeah. Jeez. Okay, let's try that again. Just let me add my frequency thing to here. What was it? Frequency, word frequency of H? Okay. Oh, balls. Okay, so I should have a word frequency list. Great. And now, frequency word of this. And maybe I want the top 10 most frequently used words. Oh, come on.
Because that is word frequency. I think you have to. Oh, it's H. It's H.
I should have used better variable names, right? So now I'm paying for it, for being lazy, for using words like H and F and G instead of really explicit variable names. So learn from my laziness. Just tired, guys. It's 2/3 of the way through the semester. Professors work really hard too. No one knows our plight. Okay, thank God. Okay, so these are the 10 most commonly used words in the Lord of the Rings books. Okay, so back to your idea. I think it's good that we should insist that sentences aren't allowed to end with any of the most frequent terms. Well, let's see what the most 100 frequent are. Is there anything in here that could end a sentence that isn't like a proper noun like Gandalf?
Frodo, Aragorn, him, one.
Okay, but like it's always the case that I could contrive a sentence that ends in any word. Look, here is a sentence that ends with the word it's. Right? Okay, so like why don't we just implement this and see if it improves our gibberish, right? So where's my gibberish line? Okay, here's my gibberish line. So I'm basically just okay, so there's the reason I say max number of words rather than number of words is this. I want to if you guys can pick this up. So remember this process where we're just walking down the dictionary by like choosing random things that come next? Why can't you guarantee, well, I guess you can, but like some paths are terminal, right? Like there are just some words where nothing follows that word. And if I happen to pick that word as like my third thing down, right, then that's not going to be a key in the dictionary. Have I explained that okay? Right? Like, I can't be sure I'm going to generate a sentence of length 10 with this process if I somehow randomly choose a terminal word. Right? So that's why I say max number of words. Right? That's what this is doing. Right? If the word is not an H, which means that there is no word that follows the word in Tolkien, then I have to stop the sentence. But maybe I can just dump this whole gibberish line and we can redesign one. Yeah.
But, okay, so if we add like an or statement with our like most frequent words, isn't that gonna like cut short most of our sentences because they're the most frequent words in the entire book?
We won't cut short though. We'll say generate another, like choose a different word. Right? We'll force our random selection to like be less random. Okay, so I'm just gonna call this the old gibber line, and let's rewrite this. Okay? So what this function is going to do, it's going to return one gibberish sentence. So how do you want to build it? Okay, sure. Like that's the basic stuff. So we're going to start with the accumulator and return the accumulator. What should the first word in our sentence be? Okay, well, let's do something like this. So while the length of the answer is less than the, and now we'll make this properly the number. We're going to force this to generate a sentence of the number of words. So while the length of the answer is less than the number of words, I want to do something. Okay, so let's say that this is our current word. So we have the current word and the next word. Maybe we'll just have current word. So I'm going to start the current word at empty because the next word is going to be taken from this. which is the set of all words that begin sentences. So that shouldn't be too bad. So I'm going to say, okay, we're going to have to take the bugs out of this. So for now, I'm just writing without an intention of compiling this. Something like the next word. Okay, so to answer, I want to add the word, and then the next word should be h of word. But if the word is in, oh no, not yet, not yet. Okay, so let's do this. Let's generate the whole sentence except for the final word. Right, and then choosing the final word, choose final word without choosing frequent word. Okay, so we need the frequency. So the frequency is, was it word frequency or frequency word? Word frequency of H. And then I want to get the frequent words, most frequent, what did I call it? Frequency word. Frequency word, I give it the frequency, since maybe I want the 20 most frequently used words. We'll get back to this. Okay. So now we have to fix this a bit. So how have I introduced errors in this while loop? Well, this is going to throw an error if word's not a key. Yeah.
We have to handle word not key and those.
Yeah, so let me do something like this. Like if word is a key in H, then I can do this. Right? Else I'll have to do something else. What is else? Well, word is a terminal word, right? There is no word that follows it in Tolkien. So what should I do in that case? Yeah.
Do the random choice.
For the same word, yeah. Well, I have to undo the last word.
We should then also take it away from the answer. So like,
Okay, I'll compile answer after
You
this.
don't necessarily have to undo the last word because you're not like assigning it again.
Is it time? Oh shoot. You guys have to go. Sorry, I got too into this. I'll write this and I'll put it online. Friday we're going to start talking about sorting. It's very important you attend that lecture because sorting is critically important to our discipline. Sorry for keeping you a little bit late.